Good evening, everyone. Welcome to our meetup. I'm Patricia Schuster. I'm one of the co-organizers, along with Sean Law, who's in the green sweatshirt, and Ben in the very back. We're very pleased to have you all here. I think this might be one of our biggest turnouts of all time. So very happy to see you here, especially in the summer. Quick show of hands, who's here for the first time with PyData Ann Arbor? Wonderful, welcome. And how many of you are connected to Midas? Great, wonderful, extra special welcome to Midas, one of our sponsors. So I want to start by acknowledging all of our sponsors. NumFocus sponsors our meetup group, TD Ameritrade provides this space for us, and Midas provides our food. A few important points before we start. Emergency exits, we have an emergency exit here. Please do not take the elevators if there's an emergency. We're always looking for feedback on how to improve our meetup, so you can provide that to us directly, or this email address here, pydataannarbor@gmail.com, or to our Twitter. And also, we're in a borrowed space, so please be mindful and clean up after yourself. So how we do Q&A here is, unless your questions are quick, hold them till the end. We'll have a discussion at the end. Please phrase your question in the form of a question. Keep your questions to 30 seconds or less. Generally, just avoid long monologues. There will be time for questions at the end and time for open discussion after the questions, one-on-one with the speaker. I will read our code of conduct now. PyData is dedicated to providing a harassment-free meeting experience for everyone, regardless of gender, sexual orientation, gender identity and expression, disability, physical appearance, body size, race, religion, or level of experience. We do not tolerate harassment of meeting participants in any form. All communication should be appropriate for a professional audience, including people of many different backgrounds and levels of experience. Sexual language and imagery is not appropriate for any of our meetup events. Be kind to others, do not insult or put down other attendees, behave professionally. Remember that harassment and sexist, racist, or exclusionary jokes are not appropriate for PyData. Attendees violating these rules may be asked to leave the meetup at the sole discretion of the meetup organizers. Thank you for helping make this a welcoming, friendly event for all. So we're going to do a quick icebreaker. I'd like you to introduce yourself to your neighbor and share what is one thing that you're looking forward to doing this summer now that the weather is so nice.
My mic's turned on, so...
What's that?
I said my mic is turned on.
Oh, okay. So, I'll do the talking. Having just moved here, I'm looking to get outside and see what's around. I like roller skating, which is a pastime you don't see very much anymore. So, I'll try to get outside and find some better roads and parking lots that do not have a bunch of, potholes in them. It's the bane of all roller skaters' existence outside. Yeah. Have you been here before?
No, I haven't. This is my first time.
It's nice so far. I don't know. You probably haven't seen much of it, but I've been trying to for a couple of weeks. Yeah. I think you're doing a good job.
It gets picked up by the camera back there.
Yeah, definitely. I will try it. It's gonna look like jungle.
No, it's pine trees, clean sand.
So what spot do you recommend to go for there?
I would try Traverse City first.
Okay, I will try it. So are you living in the country or you are?
No, here, I live here. But my parents used to have a cabin here, so every summer I would go.
Oh, that's nice. Definitely. I will check there. The Meetup, sometimes there is a Meetup. Because there is
Yeah, there are.
Yeah, for the other young, I heard good things, but I was imagining different. Not palm tree and others like California.
Oh, no, pine tree. Pine tree. Oh, not palm tree.
Oh, I'm sorry.
Pine
Yeah,
tree.
that's pine tree. Yeah, that works. That's makes it sound. Yeah, definitely.
That was my thing in my order. So any very wild and crazy plans that your neighbor had? Anyone want to share? Everyone's shy today. Well, my thing I'm most looking forward to is floating in the Huron River. Anyone else going to do that? Yeah, we should make that maybe a PyData event.
I think that's more of a 4th of July event.
4th of July, yeah. Okay, this month in data science, we like to do a little update what's going on. So this new Voila, which is a product that converts your notebooks into web apps or dashboards. Sean, do you want to say a few words about this?
Heard through Bradley Dice. Thank you for that. But that's about it. That's
Okay.
as much as I know. So go check it out.
Yeah, this sounds great. Okay, the next event will be on Wednesday, July 10th, and we will do lightning talks. So we have, I think, 4 people who have volunteered to give a short talk. So we'll have four 10-minute talks approximately. Public service announcement, Python 2.7 will retire in 6 months, and essentially support for Python 2 will be unavailable. Also, by a lot of products that use Python, they won't allow you to use Python 2 anymore. So sorry. Okay, so now we have some time for any community announcements. If anyone has an event that they'd like to highlight, or if you're looking for someone to join your company, or if you're looking for a company to join, if you want to introduce yourself and share that with the group.
Hi, my name is Ben Taub. I'm a recruiter. But we're looking for people across the country, but particularly in Ann Arbor, I'm looking for a really strong SSIS developer for a permanent role in a consulting gig, and in Detroit, somebody who is strong in Spark and Hadoop. So if anybody's looking for like a new gig, I think you'll recognize me. Just pull me aside. Thanks a lot.
Jeff?
I'm not a recruiter, I'm a developer, but I'm looking to convert some Python people to Julia. For 4 years, we use Julia to develop modeling software, and we love it. We started at .4, and we're trying to convert to 1. And we're looking for some sharp people that want to do exciting software development. So come see me if you're looking for work. We have an office in Livonia. For the right person, we'll do some remote work too.
Very nice. All right, two opportunities. That's pretty good. Any other events to share? Okay, Sean?
I have one. In partnering up with Midas in the back there, we're seeking potentially mentors. So if you have, if you're experienced in data science, working along with the university to help mentor students. So if you're interested, please either reach out, approach us maybe after the talk as well. We don't know exactly what the ask is, but at least we can put your name down to follow up afterwards. Okay?
So this could be anything from one-on-one mentoring to just a one-time meeting with a group of students for lunch. Nothing is defined yet, but if you're interested, we'd like to hear from you. All right, so now I will introduce our speaker. Alexandra is the tech lead for the platform team at SIGOPT, where she strives to build products that make the state-of-the-art in machine learning effortless to use. Additionally, she's a co-organizer of the Bay Area chapter of Women in Machine Learning and Data Science. So let's welcome our speaker.
So, machine learning and data science are really exciting fields to be in today. But what's the first thing you think about when you think about machine learning and data science? Odds are, what?
Sorry.
Oh, sorry, no, you can call it out if you want. What do you think about? What?
Getting the data.
Getting the data? Okay, that's one thing. I generally think about building a model. But yeah, getting the data, building a model, these are kind of what our minds go to when we think about these fields. But this isn't the whole picture. There's a lot of other tasks that go into the process of building a model. And as machine learning and data science expand as fields, some of these tasks, such as the infrastructure to support model training, emerge as their own subfields. So hi, I'm Alexandra. As was said, I'm the tech lead at the platform team at SIGOPT. And I'm here tonight to talk about machine learning infrastructure, which is, like I said, the subfield of machine learning that is kind of devoted to what are the infrastructure challenges unique to this field. I've talked to some of you tonight, and it sounds like there's people all along the kind of like model building journey from people who are just learning to people who understand complex topics such as hyperparameter optimization. So I hope that there will be a little bit of something for everyone to learn about machine learning infrastructure tonight. I'm going to start off with a history of the field and kind of some of the people dynamics that lead to machine learning infrastructure emerging as it is today. Next, I'm going to go into what is hyperparameter optimization and how does that introduce machine learning infrastructure challenges, and give you a really grounded look at what several different machine learning infrastructure tools look like and the technologies behind them. And then lastly, I'm going to show you some examples of successful machine learning infrastructure projects, either within large companies or open source projects that you could potentially use at your company, and end with some thoughts for the future. When I think about machine learning infrastructure, I like to think about the people who are in machine learning and data science and the people who are in infrastructure. What are the challenges these people are facing? Who are they? What did we hire them to do? So I thought this could be a little bit participatory. Who do you think gets hired into machine learning and data science teams? Data scientists, okay. What was the one in the back? Problem solvers, okay. Data scientists, problem solvers. Any other ideas? Statisticians, yeah, that was my first answer, yeah.
Business liaison.
Business liaisons, okay, that's one I didn't have up there. But I was thinking, statisticians, perhaps people who are PhDs in a scientific field. They went through a data science boot camp. We've got a lot of those in San Francisco. But mostly you think of people who love building models, people who are really interested in getting their hands dirty with data is one thing I've heard from a lot of people. And then what are we asking these people to do? So what are things that people on data science and machine learning teams do? Predict, okay, make predictions.
Write SQL queries.
Write SQL queries, okay, yeah, that's a big one.
Analyze data.
Analyze data, yeah. What?
Clean up the data.
Clean up the data, okay.
Extract the insights.
Yes, extracting insights, yeah. Yeah, so this is, when I polled some of my coworkers about what our customers are doing, generally these kind of emerge as trends. We're asking people to gather data, build models, and extract insights. And these are some of the responsibilities that we're hiring people for. And then when we build the mandate for the team, generally success for the team looks like ML models in production driving business decisions. So we're hiring, to kind of like recap, we're hiring people who are interested in building models, we're tasking them with building models, and then we're telling them success looks like building models. So we've kind of built this data science team together. Let's kind of talk through what the process of actually building a model looks like. So if you're a data scientist on this team and you want to build a model, you're going to gather some data. You're going to play around with the data, analyze it, try to build some features, do the feature extraction step. You're going to pick an ML or data science framework. You're going to train your model. And then you're going to analyze results. And this is like a typical model building workflow that a data scientist can do in R, Python, in an IPython notebook, just in a normal IDE on their laptop. This is a pretty standard process. But what happens to our data scientists when they encounter an out-of-memory error? This can happen for a lot of different reasons. Maybe their data set's too big. Maybe their data set's the right size, but once they build their feature set, that's too large. Or maybe the model just grew to an intractable size. Regardless of why, the situation this now puts our data scientist in is that they can't train their model on their laptop anymore. They want to build a model, but now all of a sudden, the tool that they're generally given, their local workstation, is not sufficient. So their workflow's got to change a little bit. Now all of a sudden, we add these extra steps. You gather your data, you extract your features, you pick your ML framework, but then you have to go and spin up an AWS EC2 instance. Or, and then once you spin up the instance, you have to set up the machines. Then you have to remotely launch the training job on this instance. And then and only then can you analyze your results. But, this new workflow doesn't really look like what we hired the data scientists to do. These tasks here highlighted in blue look like kind of the responsibilities that we hire the data scientists for, but these extra ones are better categorized as infrastructure work. The point here is that now the data scientist is in a situation of being asked to do work that's pretty different from the responsibilities that were laid out when the team was formed, or the responsibilities that were laid out when they were hired. And, okay, maybe it's fair to say you've got one data scientist and they're trying to build models using one AWS EC2 machine. Is it really that much of a big deal? If you're already proficient in building models, it may only take you a day to learn how to do this. And actually, requiring a data scientist to know a little bit of infrastructure isn't actually going to be detrimental to your data science team. It may be appropriate. The issue comes when the infrastructure scales. The issue comes when we ask our data scientists to not only be experts in data science, but we also ask for them to be experts in infrastructure as well, because infrastructure is its own separate specialty in computer science. And these are just examples of some of the reasons why our infrastructure might scale. Maybe you have, like we were talking about, large data sets, features, models that lead to out-of-memory errors. But maybe you just have a large team of data scientists and every single one of them wants to be able to close their laptop when they go home and still be able to monitor their training progress. Maybe you need access to specialized hardware like GPUs or something like that. In all of these cases, the infrastructure is scaling to be very large, and we're left asking the question, is it fair to ask the data scientists to manage all this infrastructure? But if the data scientist isn't handling their infrastructure, who is responsible for spinning up and managing the data scientist's infrastructure? Well, we have a guess of who we could ask. It's in the name. We could ask the infrastructure team. Perhaps the infrastructure team is able to help out the data science team. Which is why I want to go back to the people who form these teams. Data science, in large corporations, data science teams are relatively new as they kind of exist today. But infrastructure teams are a little bit more established. Infrastructure teams have a little bit of a different way that they work. So when we talk through who we have on these infrastructure teams and what their responsibilities are for these already established teams, we're seeing that we're hiring people like systems experts and back-end engineers. And what we're asking them to do is we're asking them to be responsible for reliability, scalability, and performance. Now, this seems honestly like a pretty good match. These seem, based on what we're seeing here, these seem like people who our data scientists could ask for help from. But here's where the tricky part comes in. The infrastructure team, having already been around for a while at the company, has their hands full with other responsibilities. In my work as an infrastructure engineer at SIGOPT, we're responsible for fulfilling customer service level agreements and keeping our API and website up and running to a certain level of uptime specification. And infrastructure engineers at other companies may be organized around similar objectives. The point is, the data science team is still feeling this pain, and the infrastructure team may have the expertise, but they've already got their hands full with a lot of other things. They've got a list of pre-existing objectives, and they're not just sitting around waiting for extra work. So it's in this environment that machine learning infrastructure emerges as its own subfield. The work that we're asking out of machine learning infrastructure is nominally some of the same kind of infrastructure expertise and tooling that we've had before, but we're asking to apply it in a pretty different way. Helping data scientists build tools is pretty different from keeping an API up and running. It requires different workloads, it sometimes requires different technologies, and there's a lot of exciting new challenges. So machine learning infrastructure has emerged as this kind of confluence of data science and machine learning users and workloads, plus infrastructure and DevOps tools and expertise. And this is a field that I am really excited about because I think there's a lot of really cool challenges here. So I've kind of talked about who are the people who are on these data science and machine learning teams, and who are the people on these infrastructure teams, and why can't they just all help each other out? I've kind of given a little bit of context as to why the machine learning infrastructure field has arisen today. Now what I want to give you is a grounded look at some different machine learning infrastructure tools and some of the technologies that were used to build these tools. So I'm going to introduce hyperparameter optimization and the infrastructure challenges, and then show you what it looks like when a data science team builds their own tools, and then show you what it looks like when an infrastructure team overhauls some of those tools. Quick show of hands, how many of you have heard of hyperparameter optimization before? Okay, cool. Every model has hyperparameters. Hyperparameters are the configurable values that you set on your model before you begin to train with any data. Different settings of hyperparameters have a very large impact on the performance of your model. And hyperparameter optimization, abbreviated HPO because it is very difficult to say a lot, is the search for the best set of hyperparameters. It's the search for the set of hyperparameters that produces the best performance for your model. These are some example hyperparameters. If you've ever built a random forest model, you may have been left wondering, how do I set the values for the number of trees in a forest? How do I set the values for the maximum depth per tree? And you can use hyperparameter optimization to help you figure out which values for number of trees in a forest or maximum depth per tree can help you maximize the accuracy of your random forest model. And this is true of almost any model out there. You can use hyperparameter optimization to help you figure out which configuration values will produce the best performance for your model. Hyperparameter optimization is a great challenge for machine learning infrastructure because it essentially trades off compute power for model performance. Hyperparameter optimization can help get you to the upper echelons of model performance, but it may require in kind of the upper echelons of model compute as well. If you're used to training your model one time and your model has 10 hyperparameters, you may need to train your model 100 times to find the best set of hyperparameters for your model. And that's with some of the more sophisticated methods. If your model takes an hour to train, this means that you're going to be left waiting about 4 days to receive your results, which in kind of like work time means that it's going to take you all week to kind of set up this experiment, wait for results, and analyze it. And when something's sitting around for an entire week running in the background, that can be kind of distracting. So we're left with this situation where we want to get the maximum performance out of our model. We want to use hyperparameter optimization to get the maximum performance out of our model. We're running into a situation where hyperparameter optimization wants to train our model 100 times, and that's taking a whole week. So we can parallelize. We can parallelize the model training across 6 different machines to reduce the wall clock time. That means instead of waiting around for results for a week, we're only waiting around for results on the order of a day. And I don't know about you guys, but for me, that would be a lot less distracting, a lot easier to kind of like on a human level manage this process. Going back to my earlier point though, you see that we want to parallelize hyperparameter optimization to 6 machines. Who is responsible for spinning up and managing these 6 machines? Is it fair to ask the data scientist to spin up and manage those 6 machines? So your mileage may vary, and I'm going to show you what it looks like when data scientists build tools and when infrastructure engineers build tools to help kind of manage the process of starting hyperparameter optimization jobs. These both have kind of like a common theme where the problem they're trying to solve is getting code and dependencies onto a remote machine, starting jobs, and then monitoring the progress. Data scientists build tools that they trust. In 2017, every new machine learning project at SIGOPT was producing a new machine learning tool that was handcrafted for that data scientist or person doing the data science project and that particular project. So each kind of like folder in our examples repository would have a different set of code for spinning up machines and doing that process I talked about, getting code onto the remote machines, launching the job, and viewing the progress. What this meant was that each machine learning project was taking time out of that project to write this specialty code in an area of computer science that wasn't related to the goal of the project. And this code was being kind of repeated by every person. Additionally, what you'll see is that the tools that ended up being produced were kind of an afterthought. The tools were kind of the easiest thing that could be built to get the job done. So, what do these tools look like? To solve the first problem of getting code and dependencies from your local laptop to the 6 remote instances, you would SCP everything everywhere. You'd use SCP to send every single file from your workstation to every single remote machine. That meant if you closed your laptop at any point during this process, you could lose all of your progress because these tools didn't do a great job of keeping track of the progress. For launching jobs, these tools generally used SSH to run commands on remote instances. You can use SSH to both log into an instance and run a command yourself, but you can also use it to automatically send a command to a remote machine to run. Finally, for viewing progress and debugging jobs, well, SIGOPT provides an API for hyperparameter optimization, so all of the tools would use the SIGOPT API to help track metadata about the job, and then they would also run remote jobs on remote instances in tmux windows. So what's happening is that each remote instance is training the model over and over and over again on different sets of hyperparameters. So when you use tmux to run a process on a remote instance, if that job fails, you can SSH onto this instance, you can open up the tmux window, and you can see a record of all the logs and the stack trace from the failed process. So it was better than having nothing, kind of rudimentary debugging tools. As I said, data scientists built tools that they trusted. When you were kind of wearing the data science hat on your project, you wanted to build something as quickly as possible, but what this kind of led to, in retrospect, is people built tools that they really understood. People built tools that they had full control over. When you built a machine learning infrastructure tool for your project, you understood exactly what was going on. You had full kind of autonomy to do whatever you wanted. You didn't have to ask anyone else to implement a new feature for you. You didn't have to ask anyone else to debug something for you. You could figure it all out on your own. But while these tools were very usable by the individual data scientists who wrote them, some of the problems lay on kind of the infrastructure and team fundamentals side. It was difficult to share tools between different people. So every project would end up needing to spend those extra couple days to build a new tool. Again, and this seems pretty simple, but you couldn't close your laptop while some of this stuff was running. And being able to have a job run asynchronously on different machines actually becomes a big deal when there's a lot of different things you're doing. Additionally, this kind of process of needing to communicate with each machine individually to send over code or to start jobs, it worked fine for 1 or 2 machines, but this doesn't scale well to 100 machines. The point is that the data science tool was customized for that person, but it still had some features that were maybe not so great on the infrastructure side. So the next thing we looked at was asking the infrastructure engineers to overhaul these data science tools, which is where I want to leave you with this caveat. I thought that this quote did a great job of explaining the kind of caveats behind just across the board introducing shared services. Creating shared services also creates dependencies and can impinge on autonomy. These data scientists were building tools that let them have a large degree of autonomy. By having the infrastructure team come in and build a shared tool, they were going to lose a little bit of that autonomy. So that's just something to think about if you're considering maybe introducing shared tools or building shared tools for your organization. Because I'm going to talk about how that played out a little bit when I get to the pros and cons section. But I always like to bring it back to kind of like, who are the users, who are the people who are going to be using these tools? So I got to be the tech lead for the infrastructure engineer overhaul. In 2018, we started the project SIGUP Orchestrate, which had nominally the same kind of process goals as the previous data science tools. We wanted to be able to quickly spin up and manage hyperparameter optimization jobs. Because, well, if you can't tell already, hyperparameter optimization is a big focus at SIGUP. So the infrastructure, oh yeah, sorry, question?
So you had infrastructure people busy. Did you get new infrastructure people, or how did you?
So the question was, we had infrastructure people busy, did we get new infrastructure people? So I think this was a little bit of a function of the team was growing. So we had a couple new people on the team, but then also we decided to step back and say, hey, this seems to be a pretty big need in our organization. We're going to carve out dedicated time and form like a separate sub-team to be dedicated to this effort. And so it wasn't part of the like standard infrastructure roadmap. It was definitely its own separate effort that existed independently. But that's a good question because as I'll talk about in the kind of future notes section, I would definitely recommend building these things as their own dedicated efforts because the infrastructure work is different enough. So the infrastructure engineers, myself included, got to use kind of the latest and greatest in infrastructure technologies to try to solve some of these issues. If you're not familiar with containerization, you can think of a container as kind of a recipe for kind of installing and managing your development environment. So it includes your dependencies and your code. And you often hear the term Docker come up because Docker is the most popular containerization technology available today, although it is not the only one. So the benefit of using containerization is that you package up all your code and all your dependencies to train your model once on your local laptop. You send this one time to a container registry, and I'm using the term container and image interchangeably. And then each machine in the cloud will download the container or the image from the registry itself. What this means is that the kind of interacting with each machine individually is all happening behind the scenes. No more needing to leave your laptop open for any more than just building your container and pushing it to a registry. To solve the problem of launching jobs, we used Kubernetes. Specifically because we run on AWS, we used AWS's EKS, which is their managed Kubernetes service. Kubernetes provides kind of a way of turning your machines into a cluster, and then it also provides a nice set of APIs and abstraction layers for things like launching jobs. Specifically, Kubernetes operates on the promise of container orchestration. So it's very well suited to launching jobs that are based on containers. And since we had committed to containers and kind of like the last step, it was a natural choice to want to use Kubernetes. Because we had used Docker and Kubernetes in this tool, it was easier to build debugging and monitoring tools. Docker and Kubernetes have these kind of rich communities behind them. And so they've got a lot of great abstractions, and it's easy to build really powerful stuff on top of them. So we packaged up our tool as a command line interface. We built abstraction layers on top of Docker and Kubernetes to allow you to view status at a glance in the command line and to view your logs. But this tool was not without its problems. It had a great amount of promise, but it didn't do a perfect job of connecting with the people who were supposed to use it. Yes, it solved these problems of kind of reliability, scalability, and performance. It provided what were in theory great debugging tools. It was highly scalable. It was easy to install. But you took away a little bit of that autonomy, and this tool took away a little bit of that freedom that the data scientists were used to having. As I heard from someone who used it, they said, you know, I'm actually not that comfortable spinning up infrastructure. But when I build my own tool, I know exactly what's going on, and so I trust that tool. When you introduce this abstraction layer on top of Docker and Kubernetes, well, it's difficult for me to understand what's going on. And it's difficult for me to trust that I'm not making a mistake that's going to cost the company thousands of dollars. Additionally, we had an external dependency. Not only was it more difficult for the data scientists to trust the tool, but they would have to go to another team if they wanted to solve bugs or if they wanted new features built. So it was more difficult to use than had been anticipated. And you kind of had these things at play, like trust and how much do your users understand infrastructure and how much do they want to understand about infrastructure. Data scientists built tools they trusted. Infrastructure engineers built tools around infrastructure principles. So how can we kind of combine these two different views and produce great machine learning infrastructure tools going forwards? In my opinion, the most critical thing to producing great machine learning infrastructure tools is going to be a tight feedback loop with your user. It's going to be very important for these teams to develop user empathy. And you can only do that by talking to your user again and again and again. As an infrastructure engineer, it was easy for me to get lost in the problem and to get lost in the idea of, I'm building a technical tool for technical people. I understand what I'm comfortable with, therefore I can build this tool to what I'm comfortable with. It had worked for me before. But when it comes to machine learning infrastructure tools, your user set is pretty different. Data science and infrastructure, as I said, are two different specialties within computer science and within the technology industry at large. They have different people that are hired for each role, different responsibilities, and different objectives. And it helps to treat them differently when you're going to build the tool. And so it's important to talk to your users again and again and have them dog food these tools, which means having users kind of internal to your team use the tools as you're developing. This is my hypothesis. The tight user feedback loop is my hypothesis as to why some of the most successful machine learning infrastructure projects today are coming out of teams at large companies. I'm hypothesizing that it's because the machine learning infrastructure teams have ready and easy access to the data science users because they're building products for an internal team. Although some of these have plans to be open sourced, and some of them may have been open sourced already. I know that Google's Borg project, which is a little bit more general, was turned into Kubernetes. But I do think that there will be some startups emerging. Startups who are dedicated to machine learning infrastructure can get this tight feedback loop by working very closely with their customers. And I'm really excited to see what's on the horizon in the next 5-10 years when it comes to machine learning infrastructure. I also want to give some love to the open source machine learning infrastructure projects out there. Many of these are based on Kubernetes clusters as a backend, but these are all available for you to kind of use within your organization right now. I've written and spoken on this topic before. If you're interested in learning more about the SIGOPT Orchestrate tool, me and my colleague Mike McCourt have written a paper. There's a blog post on machine learning infrastructure, and I gave a similar talk for MLConf NYC this year. So what I'd like you to kind of take away is a little bit about the dynamics behind how these machine learning infrastructure tools are built. Data scientists build tools they trust. Infrastructure engineers build tools that are robust. How we can kind of move towards a future where we're building robust tools that are trusted is by having a tight user feedback loop and by talking very frequently to the people who will be using these tools. Last thing, if you are interested in talking more and maybe in letting me come by your office and seeing how you work, I'm going to be around Ann Arbor until 5 p.m. tomorrow, and I would love to kind of see you in your environment and see what's going on. So if you're in this area and want to talk further, please reach out. And thank you so much for having me, PyData Ann Arbor, and I can now take a few questions. Yes.
Do you have any thoughts on ML flow or Kubeflow, and are you using that at your company?
So at SIGOPT, so the question was, do I have any thoughts on ML flow or Kubeflow, and am I using them in my company? So at SIGOPT, we build an API for hyperparameter optimization. So generally, when we do data science projects, it's to either write a blog post to showcase the power of hyperparameter optimization or to help our customers who are attempting to build models and show them the value of hyperparameter optimization. So we use Orchestrate internally or the home-built tools that the data scientists have done. And we don't have any plans to adopt those larger tools because we don't have a data science pipeline to support it. Yes?
Have you guys looked into like agile-like sort of project management tools to help sort of with that tight user feedback loop?
So the question was, have we looked into agile type project management tools to help with that tight user feedback loop? And you know what I would say for this is we are a very small startup. We're about 25 people, so we have not yet introduced agile. Okay. But that something like that sort of process where you've got a full dedicated team effort that has maybe its own product manager and its own engineers to build machine learning infrastructure tools is something like what I would recommend. So Agile would be a great thing to look into for machine learning infrastructure tools. Specifically, what the benefits it would provide is regularly talking to users and a little bit more structure around scoping out these projects. Yes?
So you have talked about data scientists, machine learning infrastructure. So how would you like define the job scope of machine learning engineer in Bay Areas? So you're from Bay Areas, right?
Yeah, I am from the Bay Area. So your question was, how would I define the job scope of a machine learning engineer?
Yeah.
So what I would say is that job scope varies wildly from company to company. And so I would read that company. If you're interested in a particular company, you're interested in what does it mean to be a machine learning engineer at that company, you're gonna need to read that company's job description to figure out what it is. Historically, people with the title machine learning engineer have taken on a little bit more of this infrastructure responsibility than people with the title data scientist. But what I'm seeing is that that's sort of breaking out and they're becoming their own team. So yeah, you're gonna have to check on a company by company basis. And that's just because the industry is so new.
Okay.
Yes?
Did you consider having any of the data scientists, one or more, join the infrastructure team, or an infrastructure engineer join the data science team for maybe 6 months, and then see what can they produce after that?
Yeah, so the question was, did you consider having an infrastructure engineer sit on the data science team, or having a data scientist sit on the infrastructure team and see what you could produce? That is something I would definitely recommend for other people who want to build tools like this. again, we're small and we're pretty resource constrained. So that wasn't necessarily a resource that we could devote at the time. Yes?
So when you spend the resources on AWS, do the users get any say of how much like parallelization, what kind of machines will be spun up? Because they will get the bill, and if it's, yes, I want the results fast, but I can launch a lot of machines in parallel, but then I will get a large bill. So is there a way for users of SIGOP to kind of see where my resource bill would be after the hyperparameter optimization?
Yeah, so the question was, using a machine learning infrastructure tool like SIGOP Orchestrate, does the user have control over which machines are being spun up and how many machines are being spun up? And from that, does the user have any control over how much their experiment is going to cost? So the answer is yes. The user has total control over how much their experiment is going to cost. All of the model training is done within the user's environment, and they specify the type of machine and the number of machine.
So 2 questions. Thank you for your talk. These infrastructure projects or products, do they carry on to production level? First question.
When you say production level, does that mean productionalizing models and serving results? So our product doesn't currently. We're focused on helping people. The question was, do these infrastructure tools carry on to the productionalization of machine learning models, which is generally scoped to mean you have a machine learning model and it's maybe accessible via an API, and someone outside of that team can hit it and ask for results. The answer is our tool doesn't. Some tools do focus on that. We focus on the problem of helping people launch hyperparameter optimization jobs, but the process of productionalizing models is a big part of the industry, and that's what some tools are focused on.
The second question is, like you mentioned sharing services. What about code sharing, like for the notebooks, the common code sharing? How do you orchestrate that and so that it can be shared for different tasks that you don't have to rewrite? Because that was one of the pain points I heard from your data scientist, that they had to everybody has to write similar code and have to, and then waste time on not sharing acceptable.
Yeah, so the question was, how do you solve the problem of sharing code maybe across different IPython notebooks? And that, I would say, is a longer answer. I don't have much expertise in that area, but I'd love to hear a little bit more, maybe offline, about your particular problems that you're facing.
So when you say hyperparameter optimization, do you mean total enumeration or do you perform research strategy?
Sorry, can you repeat that question?
So when you say hyperparameter optimization, do you perform total enumeration of all combinations or do you do any search strategy?
Yeah, so the question was about what's the method of hyperparameter optimization. So the answer is there's many different methods for performing hyperparameter optimization. When you're just trying out different configurations of hyperparameters on your own, that's called manual optimization. When you're enumerating all different possible values of, say, 4 different parameters on a sort of grid, that's called grid search. At SIGOPT, we use a technique called Bayesian optimization that underlies our hyperparameter optimization. And Bayesian optimization is a very popular technique within hyperparameter optimization today. It allows you to see better results faster than manual tuning or than grid and random search.
Could you repeat that term, please?
Bayesian optimization. Please don't ask me to spell it. Still have anxiety from the 4th grade spelling bee.
How is this infrastructure different from other ML platforms like Amazon SageMaker?
Okay, so the question was, how is this machine learning infrastructure different from AutoML platforms like Amazon SageMaker? So that's a great question. A lot of these machine learning infrastructure tools look different on the surface, but when you kind of peek in, you see that while there's a lot of tasks in machine learning, you can almost like make these checkboxes as to what are all the tasks and how many of them does each tool handle. So a tool like SIGOPT Orchestrate is going to handle a very low number of those tasks. It's going to only see check marks in the boxes of spinning up machines, launching jobs, and monitoring hyperparameter optimization jobs. But a tool like AWS SageMaker is going to have checkboxes for a lot more features. I understand that AWS SageMaker helps you with a much larger part of the kind of model building and productionalization pipeline. Where this comes into play is that different teams have different requirements for things like what Amazon is allowed to see. You know, if you're Walmart, then you can't use AWS SageMaker. But also, if you're a team that maybe can't let their data leave their machines, then you're going to want to use a tool that handles less of the process for you. And so it's really all about like what's the feature set, and then for your team, the question is, how much of this feature set are you comfortable letting another company handle for you? We're on kind of the very lightweight side, AWS SageMaker is on the very heavyweight side, and there are use cases for both.
I'll ask one last question before we wrap it up. And I just want to remind everybody too that our talks, those who are new, our talks are posted on YouTube, so look up PyData and Arbor. If you're taking notes, you want to see some slides. One last question is, for either current customers or potential customers, what should they be looking forward to in the near future at SIGOPT? So whether it's the product line.
Oh, sure. Yeah, so this is a good point because I know a lot of you are coming from University of Michigan and the Midas group. But SIGOPT is free for academic users. So if you are a current student and you are interested in using SIGOPT, sign up online. I don't know what the current process is, but email the email address that you're given and you can get free access if you're an academic user for use in your projects. And then some of the interesting things to look forward to are more tools for being able to kind of monitor your progress as you're training your machine learning job. So if you're doing this heavy duty model training like I'm talking about, you're gonna have kind of like more insights into what your model's doing while you're training it, improved UI UX features like that. We've also had a lot of great stuff come out recently around the dashboard grouping and team collaboration tools that the platform team has been working very hard on.
So I think this was a fantastic talk. Not only did we learn a lot, but we also try to remember that empathy really is a key part of being sort of in this data science field, right? And so with that, let's thank Alexandra for another wonderful talk.